Hello everyone, welcome to my U Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is intersection of two arrays, and the problem statement goes like this. Two arrays will be given to you, nums1 and nums2, and you have to return their intersection in any order you may like, and it is to be noted that the results, the element in the intersection, all the elements that will be there in the intersection should be unique. Okay, and you may return the this result in any order. For example, here let me open the board first. Okay, according to the first example, first array was 1 2 2 1 and the second was 2 2. Okay, so here what is the intersection in these two arrays? This is the intersection, but since now the intersection is although this, but since it was mentioned that element should be unique in the intersection, this is intersection, so you should only be returning 2. Okay, not other way around. Okay, so and 495 and 94. Okay, let me take this to the board. Yeah, and this one also. Okay, so what is the intersection here in these two? 4 9, and then 9 and 4 are repeated twice although, but this is the intersection anyways. Okay, so as you can see 4 9 is also accepted here. Okay, so this is what we have to return here basically, and it is mentioned that the constants are as follows, that the elements will be ranging from in both of these arrays from 1 to 1000 only, and this constant, and the length will be ranging from 1 to 1000. Okay, so you have to return the intersection. So although there may be different ways of doing it, but easiest approach that is coming to my mind is because of this constraint that these elements were, range of the elements are very manageable here. It's only from 1 to 1000 only. So what you can do, you can have a bucket here. Bucket means that it is nothing but a frequency array. Okay, so what this bucket will do, it will store whether an element is present or not. Okay, so you can have a bucket of 0 to 1000, and first of all, for the first ones, we will be having, let's say the indices of buckets are from 0 to 1000. Okay, so indices will represent the numbers, and where will be 4 1 2 3, and this will be 4. Okay, and let's say there is 9 and 5 also. So corresponding to 4 you will put 1, corresponding to 5 you will put 1, and corresponding to 9 you will put 1. And while you are traversing the second array, you will see whether those elements are already present or not. Okay, and if that's the case, then it's fine. You will anyways be returning this particular intersection. Okay, you will be able to quickly find out whether those elements were present, so you will select them only. And it is to be noted that whenever you will see an element is present, let's say 9 was, you were seeing 9 for the first time, then you will set it off to 0, so that when you will see 9 for the second time, you should not be taking 9 again. Okay, so this is one way of doing it. There may be other ways also. So, and if you ask what will be the complexity here, complexity wise it will be order of you can say n plus m, where n is the size of this particular array and m is the size of this particular array. Okay, and space complexity wise we are taking order of 1000. You may assume it a constant, anyways we will be taking this much always, so it do not vary with your input size, and does not vary. And it's totally up to you that this is one way. Another can be that you can also take a set also. Just taking a set will help. You will put all the elements in this particular set, and like this frequency array can act as a set. Inbuilt data structure it will be in any of the languages that you will be using. So whenever you will be encountering an element that is already there in the set, it means that it was present in the previous array, and so you will enter that element into the result. Okay, like if you see 9, first of all the set will contain these elements. Okay, when you will see 9 for the first time, you will know that 9 was present in the set, so you will enter it into the result and remove it from the set, so that when you encounter 9 again down the line while traversing the second array from left to right, you should not be taking it again into the result. So this is also other way of doing it, so why not use the set only. Okay, in that way set will ensure that although the space complexity here will no longer be constant only, by constant I mean that it will not be fixed, so it will totally depend upon the input size. So the space complexity wise we can say that whatever will be the size of the first array, that much space complexity we will be using. Okay, so first array will be entered into the set, so it will be order of n only space complexity. Okay, and time complexity wise it totally depends upon the operation remove in the set, how much time complexity does this operation takes in your language of choice. So you know, to remove avoid using this remove function, you can also have another set which is removed elements. It will not increase the order of your space complexity for sure, so it will still be order of n only. So this seems to be a good approach here. Okay, so taking two sets, one will be having the elements that were originally into the first array, and another set will be having the elements that were removed from the or already taken from the first array as intersection. Okay, so it's totally up to you what you name them. So let's move to another slide and write everything down in a sequential manner. So two sets, both operated on first array. Both having data of, you can say, having data or elements of first array, and one will be having all the elements that are present. Okay, all unique elements in first array. Second will be having all the elements in the first array that are already taken as intersection. Okay, all the elements in first array already taken as intersection. Okay, and yeah, that's pretty much it. Other than that, we will be just traversing the second array from left to right. Okay, this will be left direction and this will be right direction. From left to right we will traverse the second array, and we will keep storing elements as we encounter intersection, so that we will not be adding them again. Okay, so let's implement. Today I feel like using Java for the implementation. In the next implementation, which language you want to prefer in, you have two choices. I know two languages right now, so I can implement in both of them. So it's totally up to you in the next video what you want to see the implementation in. Okay, so right now we are using Java, so it will be set. You may write your comments whether you prefer C++ or Java. So I'm using these two, because they are most commonly used languages while solving algorithmic problems. So let's anyways get to the implementation without wasting any further time. So set first will be unique elements, new has set. Okay, and let's take another one as removed elements, you can say. Okay, and it will also be a hash set. Let me zoom out a little bit. Okay, now it should be fine. Okay, removed elements. So first of all, you will be adding every element into the unique elements set from the first array. Okay, so using the first array here, and adding all the elements. Okay, so now we are done with it. Now we will be traversing the second array from left to right. Okay, so two conditions should met whether we will be pushing a element into a intersection or not. Let's declare a list here, because we do not know prior how many number of elements will be there in intersection, so we are using a list here. So its size will increase dynamically, so that's why we are using it. It will be, let's call it intersection. Okay, array list, and yeah, so what we'll be doing is, if uh, the element that is currently visited is present in the unique elements array. Okay, so unique element dot contains num, and it should not be removed from the first array. It means it should not have been already taken into the intersection. So you can say that removed element should not contain this particular element that we are visiting as of now. So if these two conditions satisfies, then it means that you are having a fresh element into the intersection, and you will just add it. And one more thing that you will be doing is you will be removing it so that it should not be added into the intersection when it will be encountered in the second array further down the line. Okay, while you are traversing from left to right direction. So that's why removed element dot add. Okay, and now it should be fine. At last we have to just convert this list into array. So I guess, as far as I am able to remember, there was a function here converting it into a stream, and then mapping it to integer. Okay, using a lambda function here. This is basically just syntax, and converting it to array. Okay, so this whole thing, what it does is it converts your list of integers into int array. Okay, let's see whether this works or not for the sample test cases first. Okay, there is a error that is there. Okay, we have not provided this contains method here. Okay, and there is a return statement also missing. Okay, we have not provided return here. Yeah, it's getting accepted, as you may see. Let's submit for the final evaluation. Yeah, it's getting accepted here also. So this is how you will be solving this particular problem. If you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead.